Simplifying complex fractions. Ooh, sounds complex. What are complex fractions? Well, they're things like this, where there's more than one level of fractions. So the whole big thing is a fraction. It's got a numerator over a denominator, but then within the numerator and the denominator are smaller fractions. So you've got fractions in your fractions. Looks kind of scary, but it's really not that bad. If you can handle the rest of this chapter, you can handle this. So we're going to try to simplify something like this down to where there's only one level of fractions. And I'm going to talk about two ways you can do that. Two methods that you could use to simplify complex fractions. So method one, when you look at the numerator, it's made up of these two fractions added together. And if you know how to add and subtract and multiply and divide fractions, you know everything you need to know to do this. You can just add these two fractions together so they add up to just one fraction. You can do the same thing on the bottom, add those fractions together so they end up just as one fraction. And then you'll have one fraction on top divided by one fraction on the bottom. And if you know how to divide fractions, one fraction divided by another, that would be equivalent to the one fraction times the reciprocal of the other. So let's see how that works. So first thing we need to do is combine the numerator into a single fraction. We need to go ahead and add together 1/2 plus 1/3. And because they don't have the same denominator, we have to get a common denominator before we can add them. So the lowest common denominator would be 6. I'm going to take the 1/2 and multiply by 3 on top and on the bottom to turn it into 3/6. So 1/2 is equivalent to 3/6. I'm going to take the 1/3 and multiply it by 2 on top and on the bottom to turn it into 2/6. And now I can add 3/6 plus 2/6 equals 5/6. So that's what we get on top. Meanwhile, in the denominator, we need to add 1 plus 1/2. Now here the common denominator would be 2. We can take the number 1 and write it as 2/2, and then 2/2 plus 1/2 equals 3/2. Now we're looking at 5/6 on top over 3/2 on the bottom. So that means 5/6 divided by 3/2. And we divide fractions by multiplying by the reciprocal. So this would be equivalent to 5/6 times 2/3. Now we can just multiply across. 5 times 2 is 10 on top. 6 times 3 is 18 on the bottom. And that can be simplified because the 10 and the 18 have a common factor of 2 that we can divide out. So then 10 divided by 2 is 5. 18 divided by 2 is 9. And the answer is 5/9. So this complex fraction simplified down to just 5/9. This is equivalent to 5/9. So that's one way you can do it. The second method is the one I prefer. It's the one that I think is quicker and easier. And the way it works is look at all the individual little fractions and figure out what the lowest common denominator of all of those would be. And then multiply the whole big numerator and the whole big denominator by that lowest common denominator. That will enable you to cancel all the little individual fractions. And then you can finish simplifying. So let's see how that would work with this example. I've got denominators of 2 and 3 and another 2. A common denominator would have to be a multiple of both 2 and 3. So how about 6? So I'm allowed to multiply the numerator and the denominator of a fraction by the same thing, so I'm going to multiply them both by 6. 6 times what's on top over 6 times what's on the bottom. Now I've got to distribute that. The 6 gets multiplied by each term. So we got 6 times 1/2 plus 6 times 1/3 over 6 times 1 plus 6 times 1/2. Now 6 times 1/2 would just be 3. 6 times 1/3 would just be 2. The 6 divided by 3 is 2. 6 times 1 would just be 6. And again, 6 times 1/2, that's 6 divided by 2, so that would just be 3. So now we're looking at 3 plus 2, which is 5 on top, over 6 plus 3, which is 9 on the bottom. And so we have our answer, 5 over 9. You can use either one of these two methods. Like I said, I like this second method better. I think it's quicker and easier, so that's the way I'm going to be doing the rest of these examples. So let's simplify 7 minus 1/4 over 2 plus 1/4. I see two little fractions, but they both have the same denominator, 4, so that would be my common denominator here. So I'm going to take this whole big fraction and multiply its numerator and its denominator both by 4. So 4 times what's on top over 4 times what's on the bottom. Distribute, so it's 4 times 7 minus 4 times 1/4 over 4 times 2 plus 4 times 1/4. Now let's work out what this gives us. 4 times 7, that's just those two numbers multiplied together, give us 28. Minus 4 times 1 over 4 would just be 1. 4 divided by 4 is 1. 4 times 2 would be 8. And down here, this 4 times 1/4 would be 1. So we're looking at 28 minus 1, which is 27, over 8 plus 1, which is 9. So we have 27 over 9, and we can simplify that. 27 over 9, 27 divided by 9 is just 3. So that's our final answer. This mess here simplifies down to 3. Let's try this one. We have upstairs x over x plus 17, and downstairs x minus 4 over x plus 17. But both of these little fractions have the same denominator, x plus 17. That would be their common denominator. So I'm going to multiply by x plus 17 on top and on the bottom. So x plus 17 times what's on top over x plus 17 times what's on the bottom. Now what happens when you take x plus 17 times something over x plus 17? Well, the x plus 17 over x plus 17 divides out. It cancels. All that's left up here is just this x. Meanwhile, downstairs, we've got an x plus 17 times something over x plus 17. Those x plus 17s cancel. So what's left? X over x minus 4. And that's it. That's our final answer. By the way, if you're tempted to cancel the x's, we can't do that because this x on the bottom is not a factor. It's a term. And we can't cancel common terms, only common factors. That is, we can only cancel it if it's x times something else, not if it's x minus or x plus something else. So that's our final answer, as simple as it's going to get, x over x minus 4. Okay, how about this mess? Okay, I see sort of 4 little fractions lurking within our big fraction. What are the denominators of the little fractions? Well, some of them have x plus 1. Some of them have x. If I wanted a common denominator, it would have to have both of those as factors. We'd have to have an x plus 1 times an x to be divisible by either the x plus 1 or by the x. So that's what I'm going to multiply by on top and on the bottom, by x plus 1 times x. So when I distribute, I've got x plus 1 times x plus 4 over x plus 1, plus x plus 1 times 4 over x. And then on the bottom, I've got x plus 1 times x plus 1 over x, minus x plus 1 times 1 over x plus 1. And do you see what cancels? Here, I can cancel the x plus 1 over x plus 1. Here, do you see what cancels? X over x. Here, x over x. And here, x plus 1 over x plus 1 cancels. So with the things that cancel out of the way, there's no more little fractions lurking within the big fraction. Here's what's left. X times x plus 4 plus a 4 times an x plus 1 over an x plus 1 times another x plus 1 minus a 1 times an x. Now let's multiply things out. Get the parentheses out of the way. When we distribute, we get x squared plus 4x plus 4x plus 4. And on the bottom, we FOIL this and we get x squared plus 1x plus 1x plus 1 minus the 1x here. So that's x squared plus 2x plus 1 minus x. Now combine like terms. On top, the 4x and the 4x add up to 8x. On the bottom, this 2x minus this x would add up to just plus 1x. So this simplifies to x squared plus 8x plus 4 over x squared plus x plus 1. And neither of these can be factored. There's nothing more we can do to simplify this, so that is our final answer. How about this one? Here we see some negative exponents. We haven't seen those yet in this class. I'm hoping you've seen them before in the last math class you took. You learned what it means when you have something to a negative power. It means, well, it's the same as if you had 1 over that thing to a positive power. A negative exponent would be like a positive exponent in the denominator. So 4 times a to the negative 1 power would be the same as 4 over a to the positive 1 power. 5 times b to the negative 2 is the same as 5 over b to the positive 2. 6b to the negative 1 is 6 over b to the 1. 7 times a to the negative 2 is 7 over a to the 2 power. So this is just another way of writing what we started with. And now, yeah, that looks like a complex fraction. It's got fractions within fractions. What's the lowest common denominator? We have an a, we have a b times b, we have a b, we have an a times a. We want all of those factors involved. So how about a times b times b? A squared times b squared. That's the smallest or simplest thing that would be divisible by all 4 of these little denominators. So I'm going to multiply what's on top and what's on the bottom by a squared b squared. So we got a squared times b squared times 4 over a. A to the 1 power just means a, so I wrote it like that. Minus a squared b squared times 5 over b squared. All over a squared b squared times 6 over b plus a squared b squared times 7 over a squared. Now, what cancels? Here we've got an a squared over just an a. A squared, that's a times a. When you divide by one of those a's, there's still 1 left. Here, b squared over b squared cancels. Here, b squared over b, well, one of the b's cancel, but there's still 1 b left. And here the a squared over a squared cancels. So what do we have left? 4ab squared minus 5a squared over 6a squared b plus 7b squared. And that can't be simplified any further, so that is our final answer.